For slide 4, I'm going to talk a little bit about identifying the sounds in our system. So like I said, this is a classification problem, something that's well suited for a machine learning solution. And since we decided on that, we decided to explore some different models of machine learning that we could use. The first is a generative adversarial model. We looked into these, but ultimately decided against them because they do a little too much. All we're trying to do here is classify sounds, not produce an actual waveform right now. So we ruled that one out. The second one that we looked at was a recurrent neural network. These are really good for taking an input over a large section of data. So for instance, it's good at text classification and would be good at sound classification, except for the fact that it's a little bit too slow for our purposes. So the last model that we looked at is a convolutional neural network. These excel at image classification, something that seems like it wouldn't help us with our sound classification, except for the fact that we can represent sound in a graphical manner using a spectrogram. So by doing this, we can feed the convolutional neural net input in the form of an image and have it classify sound based on that. The second part of our machine learning solution involves finding a suitable data set for us to use. So if we have a good model but nothing to train it with, it will never be able to learn how to classify sound. So to do that, we looked through several libraries online and found 2 suitable data sets to train with, being the environmental sound classification data set and the demand data set, both of which have a bevy of environmental sounds that we can give to the neural network. If these prove insufficient, there's always the option for us to build our own, which involves us just taking a microphone around to different sections of campus and recording there to get different samples. Lastly, for our machine learning component, we need to be able to train the model. So this involves taking the data set and manipulating it to put it into bite-sized chunks that our machine learning model can actually interpret. And after that, we're moving on to our signal classification section.